Hello? What? Rational functions day 2? Okay. All right, I got it. Bye, Grandma. Oh, hi. Sorry about that. Let's grab some rational functions. We did this a little bit yesterday, but we're going to dial it up a little bit today. All right. So here is an example that we went over yesterday. X squared minus 2x minus 3 over x minus 2. When you factor that, you get x plus 1 times x minus 3 in the numerator. Remember, the numerator gives you the zeros where it crosses the x-axis. That's going to be the first thing you want to find. The denominator gives you that vertical asymptote. It tells you how far you're shifting right or left that asymptote. So if it says minus, you're going to shift it right. If it says plus, you're going to shift it left. So this one said minus 2, so there would be a vertical asymptote at positive 2. Now to find the rest of the points, you kind of choose an x from each section of the graph, substitute it in, and solve it to get the y coordinate. I like substituting it into the original equation most of the time. That's just easier for me. And your calculator can do most of the work for you, so it's not as painstaking as it appears. So let's try. Now here's a little bit of a tricky thing that we're going to deal with today. And I would jot this down. Now, I know that this is on your notes, but I would jot down a simpler version of this. So if you look, they have p of x over q of x. P is the numerator stuff, q is the denominator stuff. If you look here, it says if the degree of p is greater than the degree of q. So if the degree is greater in the numerator than it is in the denominator, there is no horizontal asymptote. So the way I would write that is if we have a larger degree in the numerator than the denominator, then there is no horizontal asymptote. That's how I would write it on my sheet so that it's a quick check back when I'm actually starting the homework. The second one, if the degree of p, the numerator, is less than the degree of the denominator, then the horizontal asymptote is at y equals 0. So if it's smaller degree over a larger degree, then the horizontal asymptote is at y equals 0. And the last one is probably the toughest one. If the degree is equal on both of them, so they're both to the second degree or anything. So let's say equal over equal. And here's how we're going to find the horizontal asymptote. So if you look, it says y equals the lead coefficient of the numerator over the lead coefficient of the denominator. So we'll say HA at y equals LC over LC. And that'll just be like, obviously the lead coefficient of the numerator goes up top and denominator goes down there. So here's what I'm going to do. I'm going to copy and paste this on each page while we're graphing to kind of just give ourselves quick access here. Let's see. Copy. Oh boy. There we go. Nice. Oh gosh. There we go. I'm just going to do that to the other two that we have to graph real quick. And then we're cruising. I'm sure this is the most exciting part of the video. There we go. All right, let's graph, huh? All right. X squared plus x minus 6 over x. So if you look, our degree up top, which again, the degree is the variable exponents. So it's the second degree in the numerator, first degree in the denominator. So if it's larger over smaller, There is no horizontal asymptote, so there won't be a flat line that kind of cuts the graph that way. Now, vertical asymptote, you get from the denominator, it's just x. It's not x plus or minus anything. So there's going to be a vertical asymptote at 0, which that is just the y-axis. So here's our asymptote. It's going to divide this into 2 halves. Now the numerator will tell us the zeros. So if we were to factor that, it would factor to x plus 3 times x minus 2. And that would tell us our zeros are at -3, 0. And this one, the x minus 2, would be +2, 0. So plot those points, -3, 0, +2, 0. And now we're kind of divided into 4 chunks. So the way we're going to figure out the curves in which direction they're going is we're going to pick an x in each of these chunks. We'll set it into the original equation. We'll substitute it in, solve it. Whatever answer we get will be the y. So I'm looking for a number that is less than -3 that we can substitute in for x. Let's say I chose -5. You can choose anything. I'm going to get my calculator here. If we substitute in -5 here, -5 squared is 25 plus -5 minus the 6 over x, -5. So if you do that in your calculator, 25 minus 5 is 20, 20 minus 6 is 14, and 14 divided by -5 is -2.8. So this is our coordinate, -5, -2.8. 1, 2, 3, 4, 5, -1, -2.8-ish is here. So that would kind of give us a curve going that direction. Now I'm going to pick a number between that 0 and the asymptote. So between -3 and 0. So I'm going to choose -1. You can choose -2. You can choose -2.961 if you want. If we put in -1 for x, -1 squared is +1 plus x. So -1 minus 6 over -1. 1 minus 1 is 0, minus 6 is -6. -6 divided by -1 is +6. So we're going to have a coordinate -1, 6. -1, 1, 2, 3, 4, 5, 6. Cruising towards the asymptote. All right. Now we're on the right half of this. We need something between the asymptote and that 0 at 2. So we're going to choose 1. That's the only whole number between 0 and 2. Now if we just substitute that in, 1 squared is 1 plus x, so +1 minus 6 over x. 1 plus 1 is 2, minus 6 is -4, and -4 divided by 1 is -4. So we have the coordinate 1, -4. We'll go from that 0, and we'll approach that asymptote, but we will not actually get on that line. And then we need a number larger than that last 0. Our last 0 was 2, so let's pick a number like maybe 4. Let's try that out. If we substitute that in, 4 squared is 16 plus x, so plus another 4, minus 6 over x, which is 4. So it's 20 minus 6 is 14, and 14 divided by 4 is 3.5. So we'll have the coordinate at 4, 3.5. 1, 2, 3, 4. 1, 2, 3.5-ish. Nice. Now, I also graphed these on Desmos.com, free to use, and you should use it to check your work all the time. So let's kind of scope out, oh boy, I guess let's destroy everything. There we go. Don't worry, that'll only happen 600 more times this school year. My goodness, how often do I do that? So there's the graph on Desmos.com. Very similar to what we arrived at. Nice. Hey, I'm pretty proud of that one. Pretty good. All right. Now this one is so bizarre. You're going to see this and be like, what? All right. Now, if you look here, the degree up on top is 1. The degree on the bottom is 2. So if you look here, the larger degree is in the denominator. So look at this red. The horizontal asymptote will be at y equals 0. So there's going to be an asymptote here. Cool. All right, I'm going to clear this stuff now because I kind of need the space. Hey man, I need some space. Come over here. Hold on. Hello, look, man, I'm recording a video. Yeah. No, I'm not gonna spit out the water. That's a dumb joke. I'm not 5. I'm just hydrating. All right. Okay. Love you too. Yeah. Happy birthday. Okay. Goodbye. I'm sorry. When my cat calls, I have to answer. It's like meow, 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 meow. You know. All right. Let's see what else we got. Now there's no right or left shift, so there also should be an asymptote at 0, a vertical asymptote. So we have a vertical and a horizontal asymptote here. Now as far as the zeros, we get that from the numerator, and the only 0 we're going to have is at positive 1. That would be at 1, 0. Now you're looking at 1, 0, and it's on an asymptote, which is weird because we shouldn't have any points on the asymptote. So this is like kind of like a hole in the graph. So it's going to cross here, but it shouldn't actually be there because if I substitute in 1, it's going to come out to 0, which is on that asymptote. So it shouldn't be there. So it's going to have a hole there. But we don't really need to worry about that right now. We have no other points to go off of. So we're going to kind of choose some x's and y's. Well, we'll choose the x's, and we'll kind of see how this plays out. So I'm going to choose one to the left of 0. So let's say I choose like -2. If we substitute in -2, -2 minus 1 is -3, and -2 squared is 4. So this would give us -0.75. So we'll go 2 to the left and down-ish there. Let's try -1, see how that goes. -1 minus 1 is -2. -1 squared is 1. -2 over 1 is -2. So -1, -2. This is enough to kind of show our curve. It's going to approach that asymptote, but never touch it. Now let's go to the right side. We already know that if we substitute in 1, we're going to get 0. But it falls on the asymptote. That's weird. Let's try it if we plug in 2. Let's see what happens. 2 minus 1 is 1. 2 squared is 4. So this is like 0.25. So we're at 2, 0.25. Okay. Interesting. How about if we did like 5? 5 minus 1 is 4. 5 squared is 25. This would come out to 0.16, which is even smaller. So it's going to start dipping back towards the asymptote. 1, 2, 3, 4, 5. A little foreshadowing here. If I chose a number between 0 and 1, like 0.5. 0.5 minus 1 is -0.5. 0.5 squared is 0.25. This comes out to -2. So we'd have a point at 0.5 and -2, which is down here. So here's why this is so strange. Because it should hit that 1, 0 coordinate. But again, it's on an asymptote, so it's like a hole. So we're going to have a curve down like this. It's actually going to cross the asymptote, but it's not going to be on the asymptote. It's going to kind of skip over it. And then it'll cruise down back close to it like this. That is wild. We're doing the most wild examples we can together so that when you get to the practice, you're like, okay, this is way easier than example B, right? That one is strange. I'll give you that. Let me see what Desmos showed us here. Yeah, kind of the same thing. So you'll see It's cruising down to the left over here. It skips over that asymptote, but then it kind of cruises back towards it. Very strange. All right. And then this is the last. Well, no, it's not the last one. I'm a filthy liar. There's one more after this. I forgot. Let's factor this. So up top, we can factor out a 2, which would leave us with x squared minus 1. Now that's a difference of squares, which we also have in the denominator. So let's see, that'd be x plus 1, x minus 1, over x plus 2 times x minus 2. The numerator gives us the zeros. So that would be negative 1, 0, and positive 1, 0. So let's go ahead and get those on the graph. The denominator tells us the vertical asymptotes, which would be negative 2 and positive 2. We haven't had two asymptotes before. So this is going to divide our graph into many other chunks. We were kind of dealing with 4 different places. And then as far as the horizontal asymptote, if you look, our degrees are the same. They're both to the second degree. So when you're doing a horizontal asymptote and the degrees are the same, you do y equals the lead coefficient in the numerator over the lead coefficient in the denominator. Now the leading coefficient is just the number in front of that highest degree. So up in the numerator, it's a 2. The denominator is a 1, and 2 over 1 is 2. So we're going to have a horizontal asymptote at y equals 2, which is just a flat line at 2. What is going on here? This is y. Now I'm going to erase this work on the left side because I need the space. Oh goodness. And I'm going to erase this too because I'll just use all that space. So we are going to come up with some other coordinates here. So I'm going to pick a coordinate in this left third, I guess. So let's see, we're at -1, -2. So I need something less than -2. Let's say I'll pick 2 points over here. I'll pick like -4 and -3. Substitute those in. Now, -4 squared is 16. 2 times 16 is 32. Minus 2. In the denominator, -4 squared is 16. So 16 minus 4. So this would end up as 30 over 12. What's the decimal for 30 over 12? 30 divided by 12 is 2.5. So we're going to have a coordinate at -4 and 2.5. 1, 2, 3, 4, 1, 2.5-ish. Okay, so in that top left chunk, if we did -3, -3 squared is 9, times 2 is 18, so we have 18 minus 2. -3 squared is 9 minus 4. So this comes out to 16 over 5, which that is 3.2. So we're going to have a point at -3, 1, 2, 3, and 3.2, 1, 2, 3.2. So this will show we're going to be curving up this way towards the asymptote. We're going to cruise down this way towards that asymptote. Great, so that third of the graph is done. We're looking at this middle kind of stripe now. We already know we can't have it at -2, we can't have it at, well, we have it at -1, we have it at +1 and +2. So really we're just going to substitute in 0 and see how that works. 0 squared is 0, times 2 is 0, minus 2 is -2. 0 squared is 0, minus 4 is -4. This comes out to +1/2, or 0.5. So we're going to have a point at 0 and 0.5. Now this is going to cruise through those zeros alongside the asymptote in both directions. Whoa! Upside down parabola-ish. Now we need that right third. So we need a number that's larger than 2. So again, let's pick a couple numbers. Let's choose 3 and 4. Now the nice thing about these is if you look at the original equation, the only time you see x's, they're getting squared. So when you do -4 squared, it's the same as +4 squared. So really, we're going to end up with the same answer for +4 that we did for -4. It's going to come out to 2.5. Same thing with 3 and -3. It's going to come out to 3.2. If you don't believe me, substitute it in yourself and check it. But again, once you square it, they become positive, and all the operations beyond that are the same. So we have 3, 3.2, we have 4, and 2.5. Cruise along the asymptote. That's our graph. That is wild. That is bananas. Let's see how Desmos look on that. That's how we do it. That's how we Desmos the graph. All right. We got one more. Now we're going to talk about those holes in the graph, the gaps. So this is very similar to our excluded values. Remember, you can't divide by 0. So even though stuff will cancel out and there won't be a denominator on problems like this, you have to consider the initial equation. So let's factor this out. X squared minus 4 over x plus 2. So that would factor to x plus 2 times x minus 2 over x plus 2. Now this is f of x, which is the same as y. If we were to cancel these out, all we're left with is y equals x minus 2. Now if you think back to your slope-intercept days, slope-intercept form, that means you would start at -2, and your slope is 1, so you'd go up 1 over 1. Or you can go down 1, left 1. And this would be your line. Wow, that is not even close to a straight line, but we'll take it. So again, that's fine, but there is a hole in this one because we have to go with the original equation. Is there anything that would make the denominator equal 0 before it was canceled? So just like we did with the rational equations, consider your excluded values. This says x plus 2, so that means x could not equal -2. Where on the graph does x equal -2? That would be here. Any coordinate in this vertical line, the x would be -2, right? So there's going to be a hole on our line when the x is -2, which is right here. So there shouldn't be a point in that hole. It should just be a hole. So I'm going to kind of erase that so I can make it look a little more proper. And then it would continue right after it. So is it an adorable graph? Yeah, of course. Is it challenging? Does it challenge every fiber of your brain? Yeah, but that's why we're here. That's why they pay us the millions, guys. Come on.